Hello. Today I would like to talk about capacitated planned location problem. And this problem is combination of transportation problem and set covering problem. If you haven't watched those videos earlier, please first study transportation problem and set covering problem. So I would like to explain the capacitated planned location problem in this given data set. In this data set, as you see, we have certain information given to us. Here we have 13 different countries: Australia, Canada, France, Germany, India, Italy, Japan, Mexico, Poland, Spain, Turkey, United Kingdom, United States. And then these are my possible production locations. So I can produce my items in one of those countries or more than one of those countries. And then also in this problem, these 13 countries are also my demand locations. So I produce my product in these countries, and at the same time, I'm selling my product in the same countries. So Australia, Canada, you can see again, demand locations are the same. I have certain demand quantities from each of these locations, such as I have demand from Australia 120,000 units, and the Turkey I have 210,000 units of demand. But also I have limited capacities in each of these countries. For example, in Canada, I have only 60,000 capacities. That's the maximum I can produce. I cannot produce more than that. So for each of these facilities, I have production fixed costs as well for these associated with capacities. For example, if I would like to operate Australia, my facility in Australia, basically I spend every year $1.2 million fixed costs. These are more like capital expenditures, big costs, and you cannot really change within a year. Also, I look at the tax rates, corporate tax rates, including states, municipalities, and federal. Altogether, tax rates. Again, these are best data that I could find online. I have corporate tax rate in, for example, Australia, 30%, and let's try to hide these so you can see easier what's happening here. For example, in Canada, I have 26.8, United States 21%, Turkey 20%, Spain 25%. You can see there are different corporate tax rates in different countries, right? So this is also given information here. Also, I have revenue information given to me here, $100 per unit. Every unit that I sell, I generate $100 revenue. Again, revenue may change based on country, but in this example, it's given that my revenue is $100 per unit. And also, I include here shipping costs. You could consider other types of costs, but for simplicity, this is a distribution network module. So I would like to talk about more shipping costs. And you can see, for example, it cost me $201 to ship from Germany to Canada. From Japan to, let's say, Canada is $45. Again, you may say these numbers don't make any sense. Again, I use these hypothetical numbers, but you could plug in basically any number you want. It's just an example in a case study. So you could easily change these costs, you could easily change the demands, you could easily change the revenue information, capacities, fixed costs, and so on. And you could even play with tax rate. So this is given information, and based on your company, where they operate, or that alternative, I could have more than this or less than this number of locations. Yeah. All right. So I put all my given information in the first section at the top. This time I will put my model, I will build my model over here. So let's say my model. All right. I will just build my model here, down here. All right. So what I would like to do is, again, as I told you before, first question that I always ask myself is, what's my objective in this model? So what's my objective? So this question is a very important question to us before you start your model, and this should, given information should help you to understand what's the objective. Yes. So in this problem, as you see, I have some revenue information given to me and I have some cost information given to me. So if I have revenue and cost, most likely I'm more interested in profit or net income. So in this case, I would like to maximize. Of course, net income is something that is really good or something that I would like to maximize. So I would like to maximize my net income. Specifically, I could say after tax, right? I would like to consider the tax effects. So I would like to know the net income. It's not EBIT, not earning before tax. This is after tax, so net income. All right. So I will calculate this value right here. At this stage, I cannot really calculate it because I need to know, first of all, what my decision variables are. So let's talk about decision variables in this problem. So what am I trying to decide in this problem? Okay, so there are some, this should be based on context. In this problem, I'm trying to decide how many units of products that I produce should come from what location or from what country, and then should ship to what country. So I would like to know the flows between these origin countries and destination countries. So that's my one set of decision variables, and which is I have 13 origin nodes and I have 13 destination nodes. So that means that 13 by 13 is 169 cells. I don't know the values of these 169 cells. That's my first set of decision variables. And in this problem, again, as you see here, this capacitated plan location problem. So I would like to also understand, should I shut down any of these? So I don't have to have an operation in every single country. I could just choose subset of these countries. Maybe I will just choose one or five countries out of them. I don't need to be everywhere, right? So that's why that's another decision variable, that whether I should keep these facilities open in certain countries or not. All right. So let's define those decision variables now. What I'm gonna do is I will just copy my country names. Okay, let's copy the country names. Like I will copy this table and then I will delete the cost because I don't want to have cost anymore here. So let's copy paste. Not shipping costs anymore. These are flow in terms of units, number of units. So again, I don't want these to be costs, so I will delete these values. And I'm gonna make sure that these values are not dollars because I want to know quantities. That's my decision variable, and I will highlight them in yellow, right? So again, I don't know the values of these yellow cells, 13 by 13 matrix here, but I will use Excel solver to calculate these values for me. So these are my, again, um, decision variables. Beautiful. All right, so what I'm gonna do is, this is my first set of decision variables, which are the flows. I wanna know how many products sent from origin A to origin B. And also I have another decision variable, as we talked about, whether to keep uh, these facilities open or closed. So what I'm gonna do is, this is my open close decision. All right. So I will just define those here as well. So I'm gonna put this one yellow. Maybe I will use a different tone of yellow so you won't get confused. That two different types of decision variables, but they are basic decision variables. So, but this open close, again, if this value is 0, that means it's closed. Australia facility is Australia closed. If this is, let's say, 1, means that the facility Germany is open. So again, I have no idea about these values either. This is my second set of decision variables. So I will just comment and say these are my decision variables as well. Decision variables. Beautiful. All right, so now I'm done with my objective, which is maximize net income, and then I define my decision variables, which are flows and also open close decisions. Beautiful. Now I need to focus on the last component, which are the constraints. I have in this case again supply constraints, demand constraints, and I added some more constraints in this model to give you the flavor of constraints. So let's start with the supply constraints. So the supply constraints here, I have again left-hand side values, and these values are given calculated, and these are shipment from. Shipment from. Again, these values should be calculated, and relationship to, I have right-hand side values. These are given to me, and these are capacities. All right. Nice. So nice. Okay. So I like that. All right, so what I'm gonna do is right-hand side capacity values are given to me, right? I know the capacities which are right here, 240,000 for Australia, the plant in Australia. Let me just reference that, and I would like to reference other 12 facilities as well. So these are my capacities. Again, they come from right here. I just referenced them, all right? And in this problem, these are my capacities. I want to make sure that I do not try to ship something more than my capacity. So that's why all these values should be less than or equal to, right? So the left-hand side values are how much or how many units am I shipping from my first facility, which is Australia. So if I sum up all these flows from Australia, it should give me my left-hand side value or shipment from Australia. Currently it's 0. Of course, if I get it with a value here, I will get a value here as well, right? So let's copy this formula down. So I would like to make sure these are my left-hand side values. Very nice. So this is my one set of my constraints right here. So let's put some red color here to represent these as my constraints, right? These are my constraints. Beautiful. And now what I'm gonna do is I will introduce my demand constraints. Again, I have left-hand side values. In this case, it is uh, shipment 2, shipment 2. And I have relationships, and I have right-hand side values, and these are again demands that are given to you. So demands are given in my given section. So let's reference them. My demand from Australia is 120,000, and if I just drag it right, I will get all those demand values for all these 13 countries. And in this problem, we don't have to satisfy all the demand, but we cannot sell more than quantity demand. Again, it depends on context. In this case, that's why I put it less than or equal to, because again, I can sell 100,000 units in the Australian market, but I cannot sell more than 120,000. So that's the assumption here, and this has to be given in the context to you. So I would just copy this relationship. These are less than or equal to. And if I see how many products I ship to Australia, all I have to do is the column sum. I sum these values, I will get these. Again, they're 0 now, but solver will calculate for me. Beautiful. So I'm done with this as well. Let's assume that in this problem I have some more constraints. So let's say I have a constraint that I can either invest in one of these 3 developing countries, India, Mexico, or Turkey, right? So let's say if I have to pick only one, then that means that my constraint left-hand side value will be, let me just put here maybe, so left-hand side value versus right-hand side value for this constraint will be, I know it's either India or Mexico or Turkey, so it is 1. I cannot invest in more than one of them. I cannot invest less than one. So 1 and only 1. That's why the right-hand side is 1. So the relationship here, that's why, is equal to, right? Is equal to. So my left-hand side value is, of course, I need to add up the decision variable associated with India, Mexico, and Turkey open close. So now it's kind of hard to see here. India is 29, I believe. This cell, perfect. Plus Mexico is 32. Let's say this one, right? And Turkey is 35 here, row 35. So right here. So if I add these three decision variables, again, they have zero values, but Excel solver will calculate them for me. Currently zero, they have to be one. So this is another constraint that assuming I have this model is given to you. There is another constraint here I would like to add. So imagine that we can invest um, up to 5 countries. Five. All right. I have 13, but maximum I can invest 5. So my right-hand side value is 5, up to 5. So it's less than or equal to, I can invest 4, 5, 4, 3, 2, 1, 0, but not 6, right? And my decision variable, open close decision variable sum should be less than or equal to 5. So if I take these values, should be less than or equal to 5. So as you see now, currently they are 0. These are infeasible solution because my left-hand side values do not satisfy the constraint criteria. All right, so this is my model, beautiful. Now I would like to, again, my goal is to maximize my net income after tax. However, to be able to maximize something, I need to measure it. And as you know, net income is nothing more than revenue minus expenses, right? Revenue minus expenses. So let's calculate that revenue to be able to do this. But it's important for me to calculate revenue and expenses for each country because my tax rates are different. So let's calculate our revenues for each of these production facilities. So let me just copy these names and maybe paste it somewhere over here, right? So these are my production facilities. And I have revenue calculations here, revenue. And then I will calculate my expenses, right? All right, so revenue, how can I calculate the revenue for Australia? Of course, it depends on how much I ship from Australia and the unit revenue. So unit revenue, again, this is like an economics class. You probably remember price times quantity will give you P times Q, right? The revenue here. So my price is $100 per unit. And if I multiply this price by quantity supplied from Australia, which is the sum of the first row, right? Because I can ship those products to different countries, which is right here, right? This value right here, left-hand side value is the summation of this entire row. So if I multiply price times quantity, that will give me my revenue generated. So of course my value will be 0 because I have 0 shipments. But if I had 1 shipment here, I would make $100, right? Let's make $1. All right. So if I have, of course, 10, I would generate $1,000 revenue, right? That's good. Okay. So what I'm gonna do now is that I don't know these values again. I will calculate these revenues for every single country. To be able to do that, I want to make sure that my revenue per unit is locked in because I'm assuming this model that I can charge $100 no matter what country my customer is located. So that's good. Now I can drag this formula down for other countries. There we go. So now I calculated all those revenue values for every single facility in the 13 different countries. So my revenue is good. Now let's focus on the expenditure. So let's go with fixed costs. So this is a little tricky because fixed cost values are given to me in my given section. If you just go to given section, you will see the fixed cost right here. But you cannot just assume that I pay this fixed cost because again, I have a decision variable here, it says open or close. If my facility is closed in the given country, basically I don't need to pay the fixed cost, right? So to consider that effect, what I'm gonna do is I'm gonna multiply those given fixed costs with their corresponding decision variable. So $1.2 million times open close decision. So of course now if I multiply those two, I will get 0. Why? Because my facility in let me just go here. My facility in Australia is closed. So if I put here 1, then my fixed cost will be changed. Let me just see whether the calculation is correct. Looks like um, I need to do again fixed cost. I thought I'd click on this. All right. So now my fixed cost is, as you see, $1.2 million because the facility is open. If I close my facility, of course my fixed cost will go down to 0, right? So I don't have to spend all this money. I only spend it if they are open. So if they are all open, 1,111, and my fixed cost will be the sum of all this, which is $29.4 million. And but again, I will calculate this, but my fixed cost in Australia is 1.2 because that's the value right here. All right. So I'm gonna copy this formula, drag this formula down for every single facility, and as you see, the total cost would be 29.4 million if they were all open. All right, I'm done with fixed costs. Now I would like to calculate the variable cost. And variable cost here, I only have shipping costs. I could have more, but in this problem, only thing that's given to me is shipping costs. So if I ship products from origin A to origin B, I need to spend money for it. So again, I will use some product here to make sure that I multiply the cost coefficients, which are given in given section, with the decision variable. So my cost coefficients here are these values associated with Australian facility in Australia. So if I, for example, ship from Australia to Australia, I have spent on average $54. So if I multiply those values with the corresponding decision variables right here, then I will observe those costs. So if I press enter, as you see here, the variable cost is currently 0. I'm not shipping anything from anywhere. But let's say if I ship 2 products from Australia to Australia, 2 times 54, I will spend $108. There you go. All right. Okay, so let's ship also 1 from Australia to Canada. So 108 plus 108 will be 216, right? There you go. Okay, beautiful. So now I would like to drag this formula down to calculate variable cost for every single facility in different countries. Again, since I don't have any shipments, these are 0, but once I get values here in decision variables, these values will be calculated as well. So then now I can calculate my total cost, which is fixed cost plus variable cost. And I can do the same calculation for all my facilities. All right. Next, I need to calculate net income before tax. Net income before tax. All right. So net income before tax is nothing more than revenue minus these expenses right here, total cost. So it looks like I'm losing money because I'm not generating money. All right, for every single facility, I calculate that. Now I can calculate my tax payments. And again, I will pay taxes based on the net income before tax. So net income before tax times the tax rates. So the tax rates are given here. Australian tax rate is 30%. So if I multiply 30% with my net income, I see that my taxes are negative because if I'm losing money here, I will have tax credit, which is negative tax. But again, if I put random numbers here, let's say if I put this many, this in the number, this many shipments, I should stop typing letters. All right, so if I send from Australia to Australia 2.3 million whatever products, you see that I will start making money. Revenue will be 236 million. I'll have 1.2 million fixed costs, 127 million variable costs, and that will give me this total cost 129 million, and income before tax 107, and from that I have to pay 30% tax, so it's to be taxed. Again, I made up this number to show you what's happening, but I will delete all those decision variables because Excel solver again will calculate them for me. I drag this formula down. Now finally I can calculate my net income, which is after tax, right? After tax, net income after tax. All right, so let's calculate my net income, which is nothing more than net income before tax minus the tax that I pay. So in this case, net income before tax 107 minus 32, net income is after tax $75 million. Let's copy this formula down by double clicking on right down corner. Okay, these are my net income values, again based on hypothetical made up numbers. So I'm done. Now I can calculate my objective function value, which is green cell, which is a summation of all the net incomes that I generate after tax. So sum of all the net income values. All right, beautiful. So $54.5 million based on made up numbers. Again, I will delete all this decision value. You can keep them the way it is. It doesn't matter. Anyway, solver will change them. So I just deleted my decision variables. Now my model is ready to go. Again, there are three components of optimization: objective function value, decision variables are these yellow cells right here, and the red cells here are my constraints. And then I calculated subcomponents on green cells because I need to calculate my net income after tax for all 13 different facilities. So now I'm all set. I can now build my model using solver. Again, if you don't have solver, you can click file, options, add-ins, analysis toolpack, go, and then make sure you solver admin is checked in, click OK. Now you're all set. On the data tab, you have solver. Once you click on solver, my objective function value is green cell, so I click on that. I'm trying to maximize this because this is net income after tax, which is net income, which is a positive thing. So I'm trying to maximize the positive things. My decision variables, I have two sets. One of them is the shipments, yellow cells right here, and comma, because I have a second set of decision variables, which are open close decisions right here. All right, so I have two sets of decision variables. Now I can add my constraints. One, I have my supply constraints. So I want to make sure that these shipped from values should be less than or equal to the 13 corresponding capacity values. All right, I add these. I'm done with that. And the second set of constraints here are demand constraints. I want to make sure ship to values are less than or equal to their corresponding right-hand side values. I add this one too. I have two more constraints. So I want to make sure that India, Mexico, or Turkey investment, I can only invest one of them. So it's equal to 1. Add this one too. And I want to make sure that I only invest up to 5 countries, not 13, less than or equal to 5. I add that one too. One more thing that we learn in security camera example is that my open close decisions are binary. They can either be 0 or 1. Specify that too. Click OK. So I set all my constraints and make sure this is checked. So the yellow cells are positive, and I use simplex LP linear programming. You click solve. There you go. So this is gonna give you your optimal solution. Okay. So let's see what's happening here. So it looks like based on these calculations, my best outcome is $76.5 million. That's the highest profit net income that I can reach. And you can see the flows. How many products should I send from what location to what location? For example, I send 120,000 from Australia to Australia, 30,000 from Australia to India, 90,000 from Australia to Japan, and 60,000 from Japan to Italy, and so on. All right. So my constraints are all satisfied. As you see, there is no infeasibility, so that I can say that this is the best solution that you can get. And looks like all I have to have is keeping the facility in Mexico open to satisfy this. That's it for today. You have a great day.